Alright, welcome back. We are going through a little task here. So we're going through a exam question, the additional sample examination for module 8, inquiry question or question 13. And we're going to try and break down this question here. So this was following through from a lesson we talked about earlier, which was nucleosynthesis reactions in stars and how that allows stars to generate energy. So in this question, there's a couple of things to unpack here. We are describing two processes that account for the energy production of stars. So when we're trying to break down questions like these, let's try and work out what exactly do they want us to do. Firstly, if it's described, we are talking about the features. What features we're exactly talking about? We're talking about two processes that will generate energy in the stars. Now, the two processes we talked about is the proton-proton chain and also the carbon, nitrogen, oxygen cycle. In terms of energy production, obviously that's due to mass energy equivalence. So that's what we have here. So let's try and answer this question as best and as concise as possible to explain, or not explain, to describe what exactly we're trying to do, or what exact process are we looking at. So obviously if it's described, the first thing you can do is probably identify what the two processes are. I have written it out on the table or on this question here, but perhaps I'll just write it out just to make it a bit neater and just to help show everyone how to do the structure. So the two processes is the proton-proton chain and we have the carbon, nitrogen, oxygen cycle. Okay, so there's kind of what we have there. What we could probably talk about here is how the energy is released. Okay, so two processes is proton chain and carbon nitrogen cycle, which converts 4 protons, or what we can write as this isotope, into helium-4. So the reason why I'm writing these symbols down is just in case if I do need to mention them later on, I can do it in the shortcut way. So, which converts 4 protons into helium, and releases energy due to the nucleosynthesis reaction. Obviously these are both nucleosynthesis. So due to the nucleosynthesis reaction and energy mass equivalence, okay, releases energy to the nucleosynthesis reaction. Should I add any more? Energy mass equivalence. So I don't really need to dive in any more than that. It's kind of explained. So I've already talked about what the end objective of these two reactions is. I've highlighted it. Now what I need to do is actually go into detail what's happening for these two. So for the proton-proton chain, okay, this will occur predominantly in low mass stars, predominantly in low mass stars with a relatively low core temperature. The core we're talking about here is the dead center of the star, not the surface temperature. So surface temperature there. Whilst for our cycle here, so our carbon, nitrogen, oxygen cycle, predominantly in high mass stars, that have a high core temperature and heavier nuclei. In this context, we're looking at carbon, nitrogen, and oxygen. I guess the final bit you should probably also add is, unlike the proton chain, okay, the carbon, nitrogen, and oxygen are purely used as a catalyst to allow for the reaction to occur. So that's the other feature. So carbon, nitrogen, and oxygen used as catalysts to allow for the production of energy and helium-4. Okay, so there goes that. Proton chain doesn't really do that. It's just relying on individual collisions. Okay, so 3-step collision of protons into helium-4. Obviously there are a couple of steps we didn't really dive into, but this would be, suffice to say, sufficient to explain, or not explain, to describe the two processes which we account for energy production of stars. Okay, so that goes back to the lesson, as I was saying from before, about the nucleosynthesis of stars. If you do have any questions further on, please ask away, but this is how you do it. If you have anything to refresh on, please look back at the slides as well. And that will do us.